So in order to set the stage for kind of hitting the highlights of astronomy, we need to talk a little bit about forces, and we need to talk about a little bit about motion, and so thus Chapter 4. So don't these actually are photographs of, is a photograph containing two galaxies. And as I hold my hands up like this, don't they look like they're face on? If we were to take that and kind of rotate it, these two galaxies edge on would look like kind of the edge of our Milky Way galaxy. So these are face on. And don't they look like they're dancing? Okay. They dance according to rules of physics. And so actually physicists can understand the collision and the dance of these two galaxies. Isn't that awesome? So not only do we need to understand kind of about gravity and motion and all that when it comes to galaxies interacting, but we need to know more about it when it comes to, although Kepler described how the planets orbit our sun, that's great, but we need more general rules. And so actually Sir Isaac Newton, after Kepler came up with his 3 laws of motion of planets about our sun, he came up with three general laws of motion. And he also came up with the universal law of gravitation. So remember the apple falling on its head, gravity sort of thing. I'm not sure if that really happened, but Sir Isaac Newton, we're going to talk about motion of objects and acceleration and that sort of thing. Notice that Sir Isaac Newton also is attributed with developing calculus, although I guess that there's like a little bit of a, was it really Newton or was it somebody else? Okay, so in order to talk about the movement of something, we have 3 terms that we need to kind of get under our belt. And they're familiar terms. Like if you say, how fast is something going? You say, what is the speed of that object? Well, you could track that object from point A to point B, the distance that that object moves, and you could track how long it took that object to get there from A to B, and then you would take the distance divided by the time, okay? And so you would get a speed, okay, or how fast it's moving. And honestly, there's something called velocity that we sometimes use interchangeably with speed. But if we go ahead and say how fast they're moving and give the direction, okay, so velocity gives another piece of information than just speed. It gives the direction. And notice how I'm kind of going like this. To me, it seems like you could give a person's velocity if you drew a picture, showed direction. Okay, so not only how fast they're moving, but what the direction they're moving in. So if instead of saying something's moving 10 meters per second, which is really pretty fast if you think about it, we could say that's a speed. We could bump it up to a velocity. If we say something's moving at 10 meters per second due east. Okay. The last term I need to talk about with regard to motion is acceleration. Now, acceleration is change in velocity. And if you remember that velocity is both speed and direction, then you have acceleration. So in other words, acceleration could be change in speed, acceleration could be change in direction of motion, or acceleration could be change in both. Okay? And the units for acceleration are meters per second, change in speed, per second that you allow that change to occur. Meters per second, meters per second squared. So we have some examples over here. These actually, this little car is accelerating in all cases. I'm going to I have a pointer here. It should work just fine. Because I wanted to kind of emphasize, I don't know if you can see this, but this says 30 kilometers per hour, the speed. And this is 60 kilometers per hour. And do you see if I go ahead and, if I'm drawing a picture, if I go ahead and put east there, do you see where I have told basically with this picture, I've given velocity, not just speed, okay? So I have speed and direction, but you can see where this car is accelerating. So down here, we could draw an arrow like this, and here we would draw, I need a different color, don't I? A longer arrow, okay, to show it's in that direction. Well, we have another scenario, and it's kind of hard to make it out maybe, but there's a car over here. I'll go ahead and kind of put the arrow a certain length. He's going 60 kilometers per hour. And notice that this car, if you look at where he ends, the speed that he ends, he's going 60 kilometers per hour. Okay? But do you see where he has changed direction? He used to be going like this. Okay, I'll put his first direction like this, and I'll put his last direction like this. Okay, he has changed direction. Okay, so any change in direction is acceleration. So this car is accelerating, keeping the constant speed. Now, before I move on, and do you see where if we go ahead and put, we're going to make that car into a planet, and inside of that curve, I'm going to put a star, and that's going to be the sun. Okay. So do you see where I know we talked about how planets go fastest in their orbit when they're closest to the sun, and they slow down when they're at aphelion? I know that. But let's just say the planets are kind of constant in their speed as they orbit the sun. Do you see where they are changing direction all the time? So planets are accelerating. Planets accelerate. Okay, sorry, as they orbit the sun. That's it. Planets accelerate as they orbit the sun. Okay, and I know I'm kind of showing this clockwise, and it's really counterclockwise motion of planets as they orbit the sun, but you get the idea. And so we're going to see that there must be something kind of making acceleration occur. Actually, that is Newton's second law of motion. So let me see if I can erase this. Hopefully you got all this. This last one actually is kind of a trick. Let's see, can I clear the screen? Yeah, erase all ink on slide. This last one, sometimes I will ask if a vehicle comes to a stop, and again, this vehicle actually is traveling, just getting smaller arrows here when he comes to a stop here. He's traveling due east, so yes, we have speed and direction here. We have velocity. But as it goes from 60 to 0, and I would ask if that's a form of acceleration, some students would say, no, that's deceleration. And you're right. But in physics, we call that change in speed from 60 to 0 acceleration. It just happens to be negative acceleration.